Good morning, everyone. Welcome to our new seminar session. Today, our speaker is Pouyan Rezvani. He's an Iranian postdoctoral researcher at the project Ptolemaios Arabus et Latinus at the Bayerische Akademie der Wissenschaften in Munich. His main focus in this project is on a medieval Arabic translation of Ptolemy's Almagest in the 9th century, to make a critical edition of the text based on the available manuscripts. He received his PhD from Utrecht University, and his new book entitled Two Treatises on the Astrolabe by Abu Rayhan Biruni, Editions, Translations, and Commentary, has recently been published by the Institute for the History of Arabic Islamic Science at the Goethe Universität in Frankfurt. Pouyan, the floor is yours.
Okay, hello everyone, and thank you very much, Andy, for your introduction. As you saw in the title of my talk, today I would like to talk about the classification of the astrolabe texts in the 10th and 11th century in Islamic civilization. And I hope that it will be interesting for the people who are working in this field. Now I would like to start sharing my screen to present the PowerPoint which I prepared for this talk. Okay. Can you see my screen?
Yes.
Okay. So I would like to begin my presentation with some elementary explanations about the astrolabe, just for the people who are not very familiar with this instrument. The astrolabe is a portable ancient astronomical computer for solving problems relating to timekeeping and the position of the sun and stars in the sky based on mapping the celestial sphere on a plane, which is called stereographic projection. So as you see in the pictures, the astrolabe contains two main parts. One is called plate and is the fixed part of the astrolabe with some coordinating lines to determine the position of the celestial bodies in the sky. And the other part that is called spider is the rotatable part of the astrolabe to simulate the rotating sky. So the spider is set up on the plate and can be rotated on the plate. In the right part, you can see the photo of an Eastern astrolabe, which was made in the 18th century in Iran and is now preserved in the Adler Planetarium. So, as you saw, I mentioned a mathematical procedure called stereographic projection, which is used in the construction of the astrolabe. The explanation of this mathematical procedure is that it's a way to map the sphere on a plane. And we can have two main kinds of this stereographic projection. One is called northern and the other is called southern. The difference is that if you choose the southern part of the sphere to project the curves and the points of the sphere on a plane, which is tangent to the northern pole of the sphere, then this stereographic projection will be called northern. And if you choose the northern pole of the sphere as the pole of the projection, and then map or project the points of the sphere on a plane which is tangent to the southern pole of the sphere, then this will be called southern projection. Normally, the standard astrolabes were made based on the northern stereographic projection. Now I would like to say a few words about the difference between standard and non-standard astrolabes. The standard astrolabe contains a spider with the circular shape based on northern or southern stereographic projection, as you see in the left side. But in the non-standard astrolabe, the spider is not circular. And in some of the non-standard astrolabe, a mixture of both types of projection is used to construct the spider and also the plate. As you see, for example, in the right side, which is a non-standard astrolabe called myrtle shaped, because the spider of this astrolabe is like a myrtle a plant which is called myrtle, and is now preserved in the History of Science Museum in Oxford. As a brief history of the astrolabe, I can say that in the 2nd century before the Christ, Hipparchus of Rhodes knew about the stereographic projection, but he didn't invent the astrolabe. Then in around 480, Theon of Alexandria probably developed the astrolabe. And in the 8th century AD, Muslims encountered Byzantine astrolabes in North Syria. And then between 8th and 15th century AD, Muslims were leading astronomers, and they made numerous improvements to astrolabes. Then in around 1000 AD, first Europeans learned about the astrolabes from Muslim Spain, and finally between 13th and 16th centuries AD, astrolabes were made in European regional schools, and Europeans became leading astronomers in the 16th century. So as I mentioned in my current talk, I would like to focus on the astrolabe texts which were written in the 10th and 11th century in Islamic tradition. According to the available sources, around 20 treatises on the construction or the use of the astrolabe were made before the 10th century in Islamic tradition, but only half of these are extant. But then during the 10th and the 11th centuries, the number of astrolabe treatises which were written for readers with different levels of knowledge in astronomy considerably increased, such that now we have around 50 treatises of that time available, and 3 of them were written in Western Islamic countries, for example, in Andalusia. So that's why I focus on 10th and 11th century in my talk. As a very general classification of Arabic astrolabe texts in the 10th and 11th century, I can categorize them in 4 general groups. The first one concerns elementary user manuals. The second one concerns correspondence between scholars. The third one concerns treatises with new theoretical developments. And the fourth one concerns advanced user manuals. Now I would like to give you some examples of each one of these 4 groups. The first one, elementary user manuals with discussions on standard astrolabes mostly, were written for the people whose level in astronomy is low and who are only interested in applications which are necessary in practice. We can trace this kind of treatises back to the 9th and the 8th and 9th century AD in Islamic civilization. An example is a treatise by Jabir ibn Hayyan entitled Collection of Theory and Practice on the Construction of the Astrolabe, which contained 1,000 problems on the construction and the standard astrolabe. So it was a comprehensive user manual for the people who wanted to learn about the astrolabe. And then in the 10th century, Abdul Rahman al-Sufi wrote a treatise on the construction and applications of the astrolabe, containing 1,760 chapters, which was again a very large, comprehensive treatise on this subject. But there were also some other treatises that were not as long, but still had didactical purposes on this subject. For example, a treatise by Kushar ibn al-Gilani entitled The Book on the Astrolabe and Properties of its Construction and its Use for Completion and Perfection, containing 60 sections. Then the second group concerns correspondence between scholars, which were usually written on very specific topics. For example, the letter by Ibrahim ibn Sanan to Abi Yusuf Hassan ibn Israel on the astrolabe. And its main contents were about mathematical proofs on the stereographic projection. Or the other example is a letter by Abu Nasr ibn Iraq to his pupil Al-Biruni on the mathematical proofs on the intersection of the azimuthal lines on the astrolabe. Third group concerns treatises with new theoretical developments. Again, we can trace this kind of treatises back to 9th century. For example, Al-Farghani and Habash al-Hasib wrote treatises with new theoretical developments on the astrolabe. For instance, in a book by Al-Farghani entitled Perfect Book, he discusses cylindrical projection, which is a little bit different from the stereographic projection. Or Habash al-Hasib discusses a set of numerical tables to plot the curves on the plate of the melon-shaped astrolabe for the latitude of Samara. So as you see, it was not about a standard astrolabe. But then again, the number of this kind of treatises also increased in the 10th century. An example is As-Saghani's book on the perfect projection of a sphere onto a plane. And this is actually the first use of conic sections in the process of constructing the astrolabes. Or Az-Zarghali wrote a treatise on a very specific astrolabe called Shakazia, which was a kind of universal astrolabe. And it was the start point of the tradition of constructing universal astrolabes. So generally, this kind of treatises were written for the people with a high level of knowledge who were interested in advanced problems. Then the fourth group of the treatises is concerning advanced user manuals with discussions on non-standard astrolabes. For example, in the 10th century, Assegzi wrote a book on the use of the astrolabe with 4 extensive chapters, which is not yet published. Or Biruni wrote a treatise entitled Treatise on Opening the Way Towards Using the Different Kinds of Astrolabes, which contains an extensive introduction and 20 chapters. And this kind of treatises were written for the people with an intermediate knowledge of astronomy, whose interest extends beyond the minimum. That's why they also discussed some advanced problems regarding, for example, non-standard astrolabes, and a little bit discussed the construction and the applications of these non-standard astrolabes. Now I would like to show you some just a few examples of this kind of non-standard astrolabes, which were discussed in the treatises included in the 4th category. For example, in Assegzi's treatise or Biruni's treatise. An example is the scorpion-shaped astrolabe, as you see in the left side of this slide. As you see, this astrolabe is named after the scorpion because according to the explanations and the descriptions of Assegzi, the spider of this astrolabe is similar to a scorpion, and it's based on a mixture of the 2 kinds of stereographic projections. Or another example is a crescent-shaped astrolabe, which was called Elali in Arabic, and it was invented by Assegzi and was dedicated to Azud-ud-Dawla, who was the greatest monarch of the Buyid dynasty in the 10th century. As Assegzi describes the construction of this astrolabe, I could reconstruct actually the general diagram of this astrolabe, because unfortunately there is no figure in the available manuscripts of his treatise and the treatises which discuss this kind of astrolabe. He explicitly wrote that I invented this astrolabe and then dedicated it to the library of the Azud-ud-Dawla. Another example is the poppy-shaped astrolabe, as you see in the right side of the slide, and as it is clear, the spider of this astrolabe is similar to poppy, so it's called poppy-shaped astrolabe in Arabic. But the point is that apparently this kind of non-standard astrolabes were made mostly to impress the rulers rather than to provide the users with more practical benefits, because in a lot of cases, if you want to apply this kind of non-standard astrolabes just to do a very simple application or to do a very simple measurement, they just make a very simple procedure more complicated. That's why I personally think that they really were not constructed to facilitate the applications of the astrolabe. But on the other hand, they provided some advanced mathematical problems for the users or the students of astronomy who wanted to know more about the theoretical layout of the astrolabe, or who wanted to tackle some advanced mathematical or astronomical problems on this subject. That's why I think that generally, in addition to elementary user manuals, scientific correspondences, and treatises on new theoretical developments in the construction of the astrolabe, another genre of treatises on the subject appeared in the 10th and 11th centuries that includes advanced user manuals with explanations on non-standard astrolabes. The structure of non-standard astrolabes has no new practical advantages, but usually causes complexities in problem solving that could be used for educating high-level students of astronomy. But the aesthetic aspects of these astrolabes may have been more important than their perhaps hypothetical applications. So one has the impression that non-standard astrolabes were suitable scientific gifts to be presented at the courts of kings in an attempt to apply for their patronage. So such treatises were probably written in the context of the scientific traditions at courts, although they had didactical aspects as well. And that's why I actually chose the title Between Education and Patronage for my talk, because I think that these kind of treatises could be good examples for the treatises which were both for the astrolabes to impress the kings and also to have some didactical aspects for the students of astronomy. Thank you very much for your attention.
Thank you. Thank you very much for this fascinating and informative talk. I'm sure there will be plenty of questions. I myself have some, but I now open the floor for discussion. So if you have a question, please write it in the chat or raise your electronic hand. Also, maybe your physical hand, we can still see you. If there is no, okay, Andy is ready, please.
Maybe I'll start. I was, while you were talking, I formulated more or less a question about in what kind of circles these texts would have been read and written. You more or less already answered my question, but I was just wondering, in terms of manuscript tradition, are we talking, are these texts, is there an indication of how many readers there were at some point? Because I mean, obviously I assume there's not a huge manuscript tradition, or how does that work? And also then maybe very specifically for those letters, are they also read in those kind of, in the same kind of contexts as these other manuscripts, or are they transmitted in a very different way because they were letters, or does the content matter more than its form?
This is very interesting question. Thank you very much, because I also thought about the number of the manuscripts of each one of this group of treatises or works. And I also thought whether there could be a relationship between the number of the available manuscripts which we have of each one of these groups and the level of the readers, or how they circulated among the students of astronomy. And then I came to this conclusion, which is still a crude conclusion, but perhaps to some extent can answer your question. For example, in case of the first group of the treatises on the astrolabe, which were for just the people who wanted to know how to use the astrolabe, and they were curious about the most common applications of the astrolabe. We have many available manuscripts, which means that they really were very well distributed and copied during centuries. But if you look at the last group, of the treatises which are more complicated and more specified with professional discussions on mathematical problems, for example, regarding this kind of non-standard astrolabes. For each work, we have only one, or in some cases, two manuscripts. So it means that it was not very common to use these works to teach the students, or actually to use them in this kind of circles. And about the letters, I think that they were not only used to, for example, answer a specific question to a certain person. Maybe this was the initial purpose of the letter, but then they got a little bit wider audience. And then because some of them are really about very basic things, which could be also used for the students or for the people who were interested, but not very professional in these things.
Thank you very much. Maybe I can also ask something. If I understood correctly your last point, you said that the non-standard astrolabe, the treatises are from the 10th, 11th century, and that might explain the use of this astrolabe. So I was wondering, do we have an evolution in the shapes of the actual astrolabes, or do we see appearing the non-standard astrolabe only in the 10th, 11th century? How does it work with the actual object?
Unfortunately, we just a few concrete examples of the non-standard astrolabes, which could, to some extent, reveal that they were not very commonly used. For example, the only example of the non-standard astrolabe with the mixed astrolabe, which we have at the moment, is that one I showed the photo in one of my slides with the myrtle-shaped spider. This is actually the only concrete example of the mixed astrolabe which we have. But we have several treatises after the 11th century in different regions of Islamic civilization, for example, in Egypt and in the western part of Islamic civilization, about this non-standard astrolabe. So it means that the tradition of using these astrolabes, maybe for didactical reasons or for discussing the theoretical subjects, continued during the next centuries after the 10th, 11th century. But according to just one example which we have of this kind of astrolabes, I would say that they were not very commonly used. So in practice or practically, they were not very common. But for the theoretical aspects, they were still used in the treatises.
Thank you very much. Dan, please.
Thank you. This is very interesting in all sorts of ways. I'm curious about the treatises that you described as both for education purposes and for gaining patronage. Is that an inference from the treatises themselves, or do we know of the fate of the astronomer with the king? Did it work? Do we know that it worked? What happened at the court after they presented this? Do you have cases where this has happened and echoes of it?
The only explicit thing that I can at the moment remember is what Sejzi wrote in his treatise. As I mentioned in my talk, he explicitly says that I invented this kind of crescent-shaped astrolabe and dedicated it to Azad-ud-Dawla, who was the ruler in that time. And apparently they continued. For example, Sijzi as a person who wrote about astrolabes and also invented some new astrolabes. He continued this tradition. So I think it could be a sign that at some point it worked out, and they could present this kind of peculiar and non-standard astrolabes to the courts to have their patronage. But in the case of Biruni, I do not have any reference to a king because maybe one of the reasons is that Biruni, as far as we know, he didn't make any astrolabe himself, but he wrote about the astrolabes. So if we just say about the practical aspect and about the people who really wrote and made the astrolabes, I think somehow it worked out for them.
Thank you. Thank you very much. I see that Johannes Thumann has a question. Please.
Yes, just a brief remark. Maybe another example is Habash al-Hasib. You said that the latitude is that of Samarra. And if that is the case, it's quite clear that this was the place where the caliph was. And then it is very likely that he dedicated it somehow to the caliph who was his patron then.
Thank you very much.
Thank you. Mara, please.
Yes. First of all, thank you. It's been fascinating and educating. I didn't know anything about the topic. Thank you. I have a curiosity, I'd say. So I'm curious about the teaching process of astronomy and like the use of Astrolabe. Since you said that some of these texts were written in order to be like teaching, let's say, hard copies, like school manuals, so to speak. Do these kind of texts bear any trace of this teaching procedure? And that's the first question. The second one is, at which point of the, let's say, cursus studiorum, the career of a student, would this student be imparted with the science of astronomy? I mean, do we know at which point, which were the preliminary sciences that they needed to know before they could approach astronomy, and that the general like cultural situation? Thank you.
Thank you very much for your questions. I think the answer of your first question could be connected to the first group of the treatises which I mentioned. We have a lot of examples of this kind of treatises containing question and answers. So actually the structure of some of these treatises are based on question and answer. The questions made by the author, and beginning with very preliminary things about the astrolabe, for example, even about the name of the parts of the astrolabe, but in the form of questions. What is the name of this part of the astrolabe? What is the name of that part? And then gradually they go to a little bit practical parts. For example, they continue with the questions like how to measure the height of a mountain by means of the astrolabe. And then they again go to a little bit more complicated questions, and just to discuss some mathematical problems, because in some cases the user had to use the astrolabe and then take some data and then put this kind of data in some mathematical procedure to get the conclusion. And usually in the last parts of this kind of treatises, the author discussed a little bit more complicated discussions or problems which were of just theoretical interests. Maybe they were only for the people who also liked to be engaged with some mathematical and theoretical problems, not only with the practical parts. So in this respect, I think they had this method, this kind of teaching method to teach the student or the people who were interested in this subject with some questions and answers. And about your second question, as far as I know, there were some classified texts in that time in Islamic tradition, including Euclid's Elements and Ptolemy's Almagest, and also there were some other texts which had to be read by the students of astronomy in between these two main texts, actually between between Euclid's Elements and Ptolemy's Almagest, which were called Mutawassitat. So they were a set of certain texts, for example, some mathematical texts by Theodosius and the others about spheres and about the trigonometric things. So as far as I know, they already classified the teaching or didactical texts, starting with Euclid's Elements, and then continuing with this kind of set of treatises which had to be read in between these Elements and Almagest, and then finally they went to Ptolemy's Almagest.
Thank you. Thank you very much. And now Adrian has the next question.
Yes, thank you very much for the talk. I also found it very interesting. I have just a curiosity. You mentioned at the beginning that Muslim scholars first encountered astrolabes in northern Syria in their encounter with the Byzantines. Can you perhaps say something about whether there is a continuity in terms of texts? So between the earliest Arabic treatises on the astrolabe and let's say Greek and Syriac treatises, similar treatises, or do they, just reinvent the entire genre, as it were?
Thanks for your question. Actually, as I mentioned in my talk, unfortunately, just a few treatises from that time are available to us. And the available texts, which were written in before the 10th century in Islamic tradition on the astrolabe, are very just elementary texts about the astrolabe with something about the construction of the astrolabe, standard astrolabe, and also some common practical aspects of the astrolabe. So in that sense, I think they got just elementary things from the Greek texts, and at the moment I do not have any translation, any direct translation from Greek, for example, to Arabic. But what I have in mind is that they encountered some treatises and maybe even some examples, some concrete examples of the astrolabe, and then they learned how to use it and how to construct it, because on the other hand, they already were familiar with for example, a principle of the stereographic projection based on some mathematical Greek texts which were translated into Arabic. Because, for example, Ptolemy also has a treatise on the stereographic projection which was translated into Arabic, and interestingly, only the Arabic translation is available and Greek one is lost. So I think for the theoretical aspects, they already were familiar. I mean, Muslims were familiar with the theoretical layout of the astrolabes based on some mathematical Greek texts which were already translated into Arabic. But for the practical aspects, I do not have any specific treatise or work which was translated directly, but it was rewrote because it was very complicated for them to write about it.
Thank you once again. We now have Dan and then Andy.
I'm curious about the classification, your 4 types of texts about astrolabes, because it jumped to my eye the fact that the introduction has 1,000 chapters. So the correspondence stands aside by genre, so that it is, but then between the other 3 categories, is it always very clear the limitation? I mean, those 1,700 chapters cannot be construed as an advanced manual. Don't advanced manual then advanced manuals contain like from the 3rd category, I think, the one with advances, don't any other types of texts contain new theoretical developments than those? You don't get anything like that in advanced user manuals. And yeah, my initial perplexion is how an elementary user manual has 1,700 chapters. Yeah.
Okay, so this is a very interesting question because the treatise with 1,760 chapters I mentioned was written by a Sufi, Abdul Rahman as-Sufi. And actually he wrote 3 treatises on the astrolabe. This one that I mentioned in my talk is the largest one. And then he wrote another one, which is a little bit smaller. And then another one, which again, a little bit smaller. And all of them are really very elementary user manuals because he doesn't discuss very advanced things, but he just splitted the subject to very small parts. And it is interesting that, for example, Al-Biruni in the 10th and 11th century, when he wrote a treatise on the astrolabe, at the beginning of the introduction of his treatise, criticized a Sufi because of his very large text on the astrolabe, and just as a kind of sarcasm, Biruni says that a Sufi wrote a treatise on the astrolabe with more than 1,000 chapters, in which sometimes the main text of a chapter is even smaller than the title. So the title is bigger than because he just wanted to, maybe it was just a kind of a way to simplify the things for the reader. So he wanted to, for example, give the main subject in the title, and then he just wrote a few words about this title. That's why he wrote a lot of chapters, but with very just small parts and a few words. And but for example, in the advanced user manuals, sometimes the author skipped some information about the astrolabe. That's why they reduced the size of the treatise, because they didn't bother the reader with just repeating, for example, the information that the addressed person or the students who supposed to be the readers of this kind of treatises were supposed to know these things in advance, because they were supposed that they already read the other user manuals, the elementary user manuals, and they already know that what, for example, what the stereographic projection is, or what the main parts of the astrolabe are. So they didn't repeat these kind of informations. That's why this kind of advanced treatises are not that large.
Thank you. Thank you very much. Andy?
Yes, two more questions from me. One is a very basic one, and the other one is kind of also linked to what you just said. The first one, the very basic one is, when you talked about the astrolabe, you mentioned it's two parts, it's a plate and a spider. Just out of curiosity, this term spider, is that a modern term, or is that really used in these treatises as well? And is that a continuation of the Greek tradition? And then maybe secondly, well, you may have already answered it more or less just now, which would be why the rise specifically of these treatises in the 10th and 11th centuries. I presume it has to do also because a lot of these other treatises just touch upon specific issues, but is there a parallel in the other scientific literature, or is it just, or are they specifically some of these if there's so many manuals, are they becoming so popular because they're actually, are they continuing the same tradition, or are they actually saying that was there one specifically with which the other authors did not agree, or is it just part of a larger tradition? Is it just a question of, for example, before the 10th century that okay, I thought you said we have about 20 treatises that are known, but were there maybe even more than that, and do we just don't know? What is that? Have you figured that out yet?
Okay, thanks. So concerning your first question, I should say that yes, the spider is the English translation of the Arabic word ankabut, which literally means spider, and it was used in astrolabe treatises in Islamic civilization, and maybe because of the shape of this part of the astrolabe, but they also used another word or another term, namely shabaka in Arabic, which means net or network. But I just wrote in one of the treatises that very surprisingly, actually, one of the authors, maybe it was Biruni or Muhammad ibn Ayyub Tabari, I'm not sure at the moment, but he explained that the shabaka, meaning the network, is used for the case that you do not move this part. But if you move it, then we call it ankabut or spider. So it was a little bit surprising for me, but I just saw it once in one of the treatises. But generally it was used, actually the term, the common term that was used in the treatises was ankabut, this spider. But I do not know whether it was derived or it was based on a direct translation from Greek or not. Actually, I didn't check it. And then the second question regarding the treatises in the 10th and 11th century and this kind of improvements, I think it was part of a general improvement in mathematics, maybe, as far as I know, because in that time we had also a lot of mathematicians in Islamic tradition who also were, of course, astronomers, and they also wrote some treatises or a lot of treatises about astrolabe. And considerable part of this kind of, for example, mixed astrolabes and mixed projections are, of course, based on mathematical proofs. So I think these developments and improvements in the construction of the different types of astrolabes and also the number of the treatises on the astrolabe were also part of or in parallel with improvements in mathematics at that time.
Thank you. Thank you very much. Do we have other questions? If not, I think that we can start wrapping it up. And I would just like to remind you before closing the session that our next of August and Sarah Parkhouse would give a paper with the title Selling Mysteries in Coptic Egypt, Religious Entrepreneurship and the Pistis Sophia. So see you all there. And thank you very much once again for this fascinating and informative talk. Enjoy the rest of the week.
Thanks.